Okay, let's talk now about rational equations. Rational equations are equations that contain rational expressions. When solving these equations, we will multiply both sides by a quantity containing a variable. When we do this, we could inadvertently multiply both sides of an equation by 0 and obtain a solution that makes the denominator of a fraction 0. In this case, we have found a false solution, also called an extraneous solution. These solutions do not satisfy the equation and must be discarded. So let's take a look at this example. We have x plus 2 over x plus 3 plus 1 over x squared plus 2x minus 3 all equal to 1. The first thing we want to do is factor the denominators so that we can see what we need to multiply by as the least common denominator. So we have x plus 2 and x plus 3 down here, and that can't be factored, plus 1 over, and x squared plus 2x minus 3 will factor into two binomials, x and x, 1 and 3, with one having a plus and one having a minus. This one has to be plus, and this one must be minus, and that needs to equal 1. Now, we can see from here that this denominator is an understood one. This one is an x plus 3, an x minus 1, and an x plus 3. The common denominator then is x plus 3, x minus 1. So we'd like to multiply through by those two terms. You have to be really careful and make sure that we multiply every term through by that. Okay. Next, we want to simplify so that our denominators will disappear. This x plus 3 and this one cancel to 1, leaving us with x minus 1 times x plus 2. Plus, here, both of these cancel to 1, leaving us with just the positive 1. And that equals x plus 3 times x minus 1, since nothing cancels on the right side. Now all of our fractions are gone. From here, we just distribute everything, combine like terms, and solve for x. Notice that the x squareds cancel when I subtract to the other side, which is really nice. And that leaves me with x minus 1 equals 2x minus 3. If I move the x's over here, that gives me negative x minus 1 is equal to negative 3. Add 1 to both sides, and we have negative x equals negative 2, and so positive x must equal positive 2. Now before we say that's our solution, we need to make sure that that's not a restricted answer. If we look right up here, we can see that one of the restrictions is negative 3, because this term right here would be 0 if x were negative 3, and the other restriction is positive 1. Notice that you couldn't tell the positive 1 was a restriction until after we had factored it. So we know that we can't allow x to be negative 3 or positive 1. Thankfully, that wasn't our answer. We got x equals positive 2 as our answer. And if we substitute that back into the original, it should check out and equal to 1. If we had obtained negative 3 or 1 as our answers, we would have no solution because we are not allowed to use either one of those. The last thing we need to deal with in section 1.1 is solving formulas for a specified variable. Here, we have the formula f equals 9/5 c plus 32. We would like to solve that for c. We're going to start by subtracting 32 from both sides. And that gives us f minus 32 is equal to 9/5 c. Now I simply multiply both sides by 5/9. That gives me 5/9 f minus 160/9. And that equals just plain c. So technically we're finished. We have isolated c. Let's look at a couple more. Here we have example 7, and we would like to solve it for p. If you notice, there are two terms here that contain p, not just one. Anytime that happens, what we need to do is factor the desired variable out. So since I would like to isolate p, the only way to do that when we have two terms is to factor it to the front. And that leaves us with 1 plus RT in parentheses. Now that we've done that, the p is sort of by himself here, and we can divide both sides through by 1 plus RT. That means that these terms cancel, and I'm left with p equals a over 1 plus RT. So let's talk about that trick one more time. Because I'm trying to get p by itself in this problem, and there are two terms that contain it, we have to use factoring to isolate the p. So anytime you're solving for a variable and it appears in more than one term, get the terms it appears in on one side, factor out the desired variable, and then divide by what's in parentheses. And that should leave you with your specified variable isolated. For our last problem of the lesson, we're going to look at 1 over y is equal to 1 over x minus 1 over z. We would like to solve that for y. First thing I'm going to do is rewrite it. 1 over y equals 1 over x minus 1 over z. Anytime you're dealing with fractions, it's a good plan to multiply through by the common denominator and clear those out. So we'll do that first. The common denominator here is x, y, z. So I'm going to multiply every term through by x, y, z. Then I'm going to simplify this by canceling the y's, leaving me with x times z times 1. And that equals, on this side, the x's cancel, leaving me with y times z, minus, here for this term, the z's cancel, leaving me with xy. So notice that I have 3 terms left, and I'm trying to get y by itself. 2 of these terms contain y, the yz and the xy. So I need to separate the y from the other variables. To do that, because there are 2 terms, we're going to use our factoring trick. We're going to factor the y to the front, leaving us with z minus x in parentheses. And finally, we're going to divide both sides by z minus x. And technically, the parentheses aren't necessary here. Canceling these and leaving y by itself. So we have y equals x z over z minus x. And that wraps up section 1.1.